right, so here's a diagram of what we're trying to do. I want you to pay attention to these junctions here, where the veins are meeting together or they're leaving. So conjoining junctions where they meet together, or bifurcation junctions where they leave and separate into different vessels. I was hoping to get it to terminate right before the conjoining of these two veins here. So right before it joins, I tried to get my catheter tip to stop and exit right before that conjoining junction. And the reason why that's so important is we are trying to allow the flow. Make sure it's small enough. We're trying to allow the flow from the blood, from the collateral branch, to dilute the medication. So by the time it gets up to this junction right here, it'll be diluted by the blood. And it looks like there's actually another junction joining right here like that. And so you'll have less of an irritative effect because the blood has diluted this medication. Not only that, but when you get up to here, you have all this extra flow rate that's decreasing the irritation from the medication. There's a bifurcation here and a conjoining here. If I settle the catheter tip right about here, this is the lower lock hub, and this is our catheter point. If our catheter ended right there, or even let's say right about here, at that point, the blood flow from, let's say the medication is going in from here, and then it's going to split off between here. You have all this collateral flow diluting that medication till it has very little effect on the veins. And if you look carefully, I know this is just a diagram, but look at how much of the medication is actually irritating directly into the vein. It's a very small amount, and everything else around here is being diluted by the blood. Now let's see what happens if we put it in a suboptimal location. So let's say we ended the catheter tip right about here. You would think that this gigantic area and diameter of the vein would be great hemodilution. It probably is to this patient or to this person. But remember, our patients don't have muscles this big. So, I mean, think about it. If we want to scale that, if we put a 20 gauge catheter, it's probably relatively more like this to most of our sick patients. And then you really don't have a lot of blood flow flowing around that catheter, because it was choked up by the diameter of the catheter. So this is the diameter of the catheter, and this is the diameter of the vein. So not that much different. And so your catheter to vein ratio is a lot higher. And so that mitigates all this work, and all this potential hemodilution now gets choked up and mitigated. And there is traffic jam here, which doesn't allow for hemodilution except from this collateral flow. So this collateral vein is what's helping to dilute it, but you're missing out on all these other potential hemodilution pathways further behind or further distal, so that you get a lot more collateral flow to really dilute that medication. So if I want to end here, I need to insert at about, so I'll have to insert at this point. That'll be my insertion, level of insertion here. That way we make sure the tip terminates post first. It's probably closer up here. That second one up there. Yeah, that one will get us past the valve here, these two valves, and it'll get us right before that valve. So we're going to try to settle the catheter here right in between.